PCI Express to
slides that are functional. And
Yes. Hey, so does I. Look the same, but I have it down. Yeah, great now. I was sitting here. Good news. Well, that's a really good point. Second. Oh, I see. Yes. He doesn't like my Android.
absolutely any day.
That I work for a retail.
Did it to him. He's
This is
frying
for
pan.
It
And
does
it's
have
just-
and by implication, it does USB, but it does USB. It just yeah, three things.
Yeah.
And on the back, it only does two things. It does USB.
The real story is why she
It doesn't have a motherboard.
It's just going to be so frustrating.
Mr. Allen, does what because
We are blaming again something.
What's the best USB-C project you find? Well, next to myself, videos.
What do you use, brand new laptop?
What do you use? Yeah.
Yeah.
What do you get like?
You mean like you want like that one?
Well, I have a bunch of USB adapters or devices that I want to connect.
Yeah.
Then the HDMI.
So, for example, the one I just gave up there's one that goes from USB-C to HDMI and USB to
But the USB standard is like kind of fucked up, right? Because there are so many different things that go over USB-C.
if you want to do more stuff,
I've already, probably don't let me forget that I've already.
it's fine. There are these colorful docks which have like three.
Yeah,
ports
they
and
do have,
two
like,
port
big
on it. Like if
racks.
you're really serious about this, and you want more stuff, you need to buy those $200.
Hey, look, Cisco expense, right? So,
Oh, thank
Yeah, I'm gonna have Ethernet.
Done.
Or it's only 100. It was Ethernet, HDMI. I think there was DisplayPort, and there was a few USB, just standard USB.
So there's one standard at home if you want to use big stuff, then you get one of those colorful docks.
The real question is, when are we going to start referring to USB-C as USB? And not.
I have two. On my speaking of USB-C.
right here.
Oh, look at that.
And also, when Apple started shipping USB-C chargers,
I got this thing 2 years ago and had a USB-C.
Wasn't
a
a
charger.
charger, like, if I buy a new Apple and the brand new flagship, there's the one.
Oh, no.
Are we ready to go?
That's seems like a bit of an oversight.
There should be one blue sheet thing sign making its way around. There's another one up here as well.
Yeah, one is fine, one is fine.
Yes, so this one we're starting to circulate.
Welcome to Capport Portals.
So, would you call this a captive audience?
Captivated audience.
It's only Tuesday, big.
Note well the things that need noting well. Has anybody not seen this before? Yes, Michael is Jabber scribing for us. Do we have a note taker? A taker of the notes. Believe we can't get started.
I can just go into the Etherpad.
But you will be presenting at some point.
So I can do it, but someone else should be in there too.
Mukesh, would you like to take notes? To be use Etherpad.
You just have to help out.
Go to the agenda HTML page and. I guess the first thing up is agenda bashing. We have some updates on documents, milestones, and then we will have a discussion on the ICMP option. Yes, we have the Kyle Laros Variety Hour, followed by an update on the architecture document since Mr. Dolson could not be here this time, and an update on PVDs from Tommy. So there was another hackathon and more participation at the hackathon. There's some implementation work, and Kyle has a presentation. If you download the document, the link materials are linked there. Midori and Kier also, I guess, undertook a project remotely, and they sent some documents that are linked. All the materials are in the GitHub working group materials repository. There's also some code. They tried to see about detecting captive portal things. They have some code for that. Right. So we had a milestone to have a protocol to discover and interact with captive portals. We adopted an architecture document in Prague. We still have 7710 and PVD in the mix. We need to decide at some point what to do about that. Hopefully today. And I suppose that will come up in the architecture and PVD latter half of this session. We also have a milestone for having an API document, which we adopted in Prague, but there was no -IETF upload. There was no GitHub version upload. We tried to email the original authors. Does anybody know if they are around? Has anybody responded to them? They haven't responded to either of us. And so that being the case, Tommy has expressed interest in taking over some authorship. Would someone be willing to help him out as co-author? Is that, can we note that down somewhere? Okay.
So just to clarify here, we're exercising our authority as chairs to take the work now and assign it to these people. We can choose editors of documents. Ideally, since this was not an IETF, this was not an adopted document, we'll continue to try to get permission of the original authors on this one. But given the amount, to actually take their text, they have submitted it. So under copyright, I think we're okay. But there's not a lot in that document anyway. We could start over if you really felt like doing that. And we would leave that up to the editor's discretion on how to proceed.
If you both send us some GitHub coordinates, we can add you to the repository. That'd be great. Thank you both. We'll be having to discuss some ICMP stuff that came up on the mailing list, and I wanted to have a couple of slides of architecture since we mostly have walls of text today. This is the captive portal architecture diagram for those of you that might need to be reminded. This is available in the document. This is just the SVG that's in the repository. It's obviously very functional element-y. This is from David Bird's presentation on ICMP, which is also kind of a functional element diagram. It clearly delineated thank you. Clearly delineated that there are multiple sort of off-network authentication vendors that need to be supported. And highlighted that there's a sort of an enforcement point. But as we've been talking about, what is a UE identifier? Is it an IP address? Is it a MAC address? Is it some other kind of token? And how is that learned? And how is that communicated to the API? I felt like I needed to put something into some sort of like a network architecture diagram. And so here I drew like a client like UE device connected to an AP. I imagined you might have a downstream laptop like USB tethering through that device as well. So there's a set of infrastructure that's on link. There's obviously a cascading set of highly redundant router connections to the internet because it's a really well-run venue, and there are multiple login vendors that need to be accessed. And so we need to consider the locations of the enforcement point. Where's the API endpoint? Where's that first web endpoint before you might get redirected off to one of the login vendors? And these architecture decisions, like what we decide is in scope and what we decide is out of scope, are going to affect what we think of as UE identifying tokens, and also the guidelines for DHCP4 and PVD deployment. PVD and DHCP4 will function very differently. BBD needs to be on link, whereas DHCP4 only can be relayed from off link. So we'll have to think about what that means. We can come back to these slides later, but I want to just sort of plant some pictures in your mind. I think, Kyle, are you ready to get some ICMP here? Let me come on, open with preview. Oops. You can point the clicker at me. Actually, just the button work? Just the laser?
That wasn't easy. They don't work. I was confused by the lack of.
The laser works.
I probably don't need a laser since I don't have any diagrams.
Yeah, you could laser point to your text. So, alrighty.
Hey everyone, I'm Kyle Rose, and I'm going to talk about how we can identify the user equipment in the Capport portal architecture so that stuff works. Next slide, please. So, in particular, I'm going to just give a brief introduction of what I'm talking about, and then I'm going to try to describe the problem and why it needs to be solved. And then I'm going to lead a discussion, hopefully with lots of input from you guys, to come to a conclusion as to what we want to do, or what do we want to limit some scope, widen some scope, maybe explore some stuff further before we make a decision. But either way, this is meant to be interactive, and peer-to-peer. Don't relay through me. All right, so next slide. Ignore this slide, it sucks. So I'll just give you an introduction. So basically what we're, in the architecture, we have a few pieces that are communicating with one another. You have the user equipment that's trying to send packets out to the internet, and an enforcement device is blocking those packets or allowing them through, and it may be responding to the block with some sort of ICMP unreachable message or ICMP Capport portal message. On the other side, the user equipment is going to communicate with an API device, API server to understand whether it's captive. Maybe it'll go to a login page to log itself in, and then this login page, API server, whatever it is going to communicate with the enforcement device to get the status or actually log the user in. And underlying all of this is the user equipment itself. There's going to more than one of them, and all these devices need to agree on how to identify the user equipment so they can make the right decision. Next slide. And that's the problem, right? So there's a whole bunch of ways of identifying a device on a network. You can use layer 2, you can use layer 3, so on and so forth. And we want to sort of come to a conclusion as to what we want to recommend or require that implementations of the architecture actually use for identification. Next slide. So as I said, some options. You could use the L2 address or the MAC address, and it's kind of what they're doing. Like I think a lot of at least access point style Capport portals are doing right now. In fact, my hotel, for example, when I log into the Capport portal there, it actually sends my MAC address in the URL to the to the login page. So I mean, clearly that's being used right now. I can use the layer 3 address, so IPv4 or IPv6 source address to identify the device. Maybe you want to use some combination of that and a port if there's a NAT involved, or maybe we want to do something new and have something that everyone agrees that isn't necessarily directly derived from an address associated with a device, but still uniquely identifies it. So the session ID, if you will. Next slide. So another thing that I want to discuss, aside from how to identify the device, is how to communicate this identification to the API server from the from the user equipment. So I mentioned, implicit identification versus explicit. When I say implicit, I mean that the API infers the identity of the user equipment from the request that the user equipment sends to it. So, for example, if I make a REST API call to the API server could use the source the source IP of the request to identify the device, and then send that source IP down to the enforcement device to make the query. Now that has some some trade-offs in doing that, some limitations. which I hope to discuss later. Now, explicit, when I say explicit, what I mean there is it's actually the user equipment will package in the API call the information that it is using to identify itself. And the example I gave earlier in my hotel is an example of the explicit way of communicating that information. Next slide. Discussion time.
Discussion time. I just want to poke on that a little bit. Martin Thompson. So the example of the MAC address in the URL has a number of interesting implications for this design. I don't think it is explicit in the sense that the client was involved in making that MAC address appear in that thing. So if you think of this from the perspective of the deployments that we're talking about here, your first point of contact for an API or a login service would be the thing that's adding the MAC address to that information. And it would be that device that has explicitly added the MAC address to that, but the client has implicitly identified itself to that. The fact that you're then being redirected off to something else with extra information being passed along with that redirect doesn't change the fact that that is actually implicit on that first interaction.
Yeah, I guess the question is the user equipment aware of its identity at all? Is that kind of what you're getting at?
The user agent isn't aware, the user equipment isn't innately aware of the fact that this particular field happens to carry its MAC address. In fact, it could be completely opaque, and in fact, it probably should be completely opaque, because in that case, I could put his MAC address in that field there. And if we get into discussions of these things, and I think we actually should, we should cover the security ramifications of these things.
Yeah, I have a slide at the end talking about the security.
So if I may interpret, ask Martin for clarification, we could also think of this as being active or passive from the client's perspective. Is that correct?
Yeah, I would say
Yeah.
passive
So they-
equals implicit and active equals explicit.
That makes
Yes.
sense to me.
Yep.
That might be better terminology.
And I think part of the reason why we want to talk about these things is because this has implications for the ICMP question as well.
Yep.
Whole giant ball of wax.
Rick Taylor, just a qualifying question, I suppose. You talk about user equipment here, but we've heard now user agents. Okay, cool. And so everything's a user agent. Okay, because I don't work for a browser vendor, but I still need captive portal support. So I'm much more interested in the fact that you're using user equipment, and I'm really pleased to hear that. And I'll shut up and sit down.
But you can. David Bird actually introduced me to that technology, and he's also a captive portal guy. So yeah. Anyway, I guess go to the next slide. So at the hackathon on the weekend, I tested out a few different things to see if they would work. And I tested out it was 3 scenarios. One was the user equipment made an API call with the L2 address embedded within it. And another one did the same thing with the LI3 address. And finally, I also tried out doing it implicitly. So having the server infer the address based on the source IP of the device, and some interesting results. Like the first 2 just worked. It's something we had already done basically with the hackathon in Chicago. But the third one, what I found interesting there was sort of 2 things. First, it was simpler. I was able to cut out like half the code because now you didn't have a bunch of stuff parsing fields and understanding stuff. The other thing is I also messed it up originally because my route to the API server was not the right one. I chose the API server was on it got a different source IP than the one that the the enforcement device was seeing. So they basically disagreed. And the important point there was that there's some restrictions on where the API server lives in order for this sort of in order for it to properly infer the identity of the user equipment. In this case, if it was using a source IP, it had to be in the same sort of domain as the enforcement device so that it could agree on the same IP address with the enforcement device. So anyway, next.
May I inject a clarifying question?
Yes.
In your testing, was it v4 only or was V6 involved?
This was V4 only. I wanted to get to V6, but I didn't get to it.
So, yeah, because an open question in my mind is still IPv6 and all of its multitude of addresses that are possible for the client to use.
All right, so let's discuss. I'm going to go through a few different things and ask about pros and cons, and talk about security, talk about the session ID we mentioned, and hopefully I get a lot of feedback from you guys. Right. Next slide, because I have some prompts. All right, but if you want to just talk.
Yeah, sorry, I'll just jump into the mic. Rick Taylor again. So in the deployment model you were testing there, sorry, I may have missed this in the first two slides. I was still in the bathroom.
I don't think you missed anything.
Okay. So the end user equipment was attempting to access the internet.
Yes.
Was being hit by your protection device.
Mhm.
That was then going, I don't know whether this person is allowed to access the internet. So was the protection device therefore forwarding the request to the API, or was the redirect was coming from the ICMP back to the user equipment, and it was then going to the API? Hence your two different subnets, two different IP address.
The latter case. So the ICMP.
It was the second one.
The enforcement device replied with an ICMP unreachable, which in my user equipment interpreted that as crap. We're behind Capport portal. I'm going to go to my well-known API
Cool.
and send it my information.
Thanks.
How did the client learn the API endpoint?
I faked DHCP by just hard coding it. That's something else I would like to get around testing out in a hackathon at some point.
So I think the reason this came up in the context of the ICMP draft was the ICMP draft incorporated two different sort of things, but in the newer option of the in the new ICMP option, it incorporated some extensible metadata at the end that included all manner of like a session ID, but also lots of other information could be communicated to the client, which is the only thing that's going to work across multiple links, right? So the question is, how aware of the how active should the client be in needing to know about this stuff? Yeah, Darshan?
So Darshan Thakur, Cable Labs. So I think Martin earlier, right? So if you go into the security implications, it looks like at least the client, there should be some amount of explicitness in the sense that the client should at least have received something that it holds back and sends back in order for it to identify itself. Then that would probably have better security. Maybe I'm wrong, but that might have better security characteristics than the implicit, where the client doesn't know anything, which means that you're just inferring based on.
But if it's implicit, then the client's just using the same information used to communicate with the enforcement device, which means it's a little harder to fake. It's a little harder to spoof. If it's explicit, if the client is putting the information into the API call, it can put whatever it wants.
True. Yeah. All right. So that maybe that's a discussion. Okay. So but the thing is, in the implicit, the risk is then that you may actually infer the wrong thing, right? Different endpoints may infer the wrong thing, and if the client can still go ahead and spoof its MAC address, if let's say you are doing it implicit based on, right?
Yeah.
I know if I know that you are doing an implicit, then I can spoof my MAC address, and then that's all I need to really do, if that's what you're depending upon.
Yeah.
I think I was about to make the same point. The implicit data is still kind of explicit. It's just configured at a lower level. You know, I can change my MAC addresses if I want to jump onto somebody else's thing. Just off from, I'm sort of free thinking here a little bit. I think you've got the model right. There's the user equipment that actually wants the access. You've got the protection device, which is providing the access, allowing the access, and the API, which is doing the permission authentication. So is this person, authorization, is this person authorized to be given the access? So I think those three entities need to be involved in this. So the protection device needs to be able to go to the API server and say, I've had this person with this identifying information I may have implicitly discovered. The redirect goes back to the user equipment that then says explicitly, I am me, and to the API server, and the API server, and it makes the job harder at that point for the API server, but then he has the implicit and the explicit information with which to make the decision. That's a big problem to solve, and just
Well, that's kind of where we were going with the
Yeah.
whole session ID. And there's a few proposals on the list about how to actually use a session ID, and maybe we can talk about them. I didn't call them explicitly here, but
How to generate that session ID, whether you
Yes.
can go into ephemeral keying and some fun crypto stuff at that point.
Tommy Polly, Apple. So when we're talking about kind of building on that, the explicit or implicit identifiers, I think we also should be discussing like which legs of the triangle are using which identifiers and when. So I know that, yes, the current ICMP draft has a lot of identifier stuff that can come back from enforcement to UE. From looking at the hackathon stuff and looking at how we would do implementation of that on a client, that can be problematic for a lot of reasons, like getting just the normal ICMP message that you've been administratively blocked. It's quite simple. That doesn't require changes. Pretty much any platform should be able to do that today. Getting all of this other extended information, I think that's going to require Android, iOS kernel changes a lot.
I think Eric and I were discussing that.
Yes, and that may be very difficult to get up there. And again, may not be appropriate for that identifier. I think when we're talking about the API, UE to API leg, there's a lot of flexibility about how we want to do the identifier. We can have relatively complex identifiers. They can be encrypted. They can, we can do what we need to do there explicitly if we want to. What I don't understand, maybe this has already been discussed, is if we were wanting to communicate from UE to enforcement device what our identifier is, I mean, that's just the data path for us, right? That's like, I'm just sending web traffic. And am I annotating every packet with this other explicit identifier that is like my IP address, but not my IP address?
That's certainly an option. I don't know if we want to go that way.
I don't think we're going to be modifying all packets coming out of the device.
I agree. But I mean, ultimately, I think that's the question of correlation as it was raised on the mailing list. It's how, if we are using an opaque identifier that isn't in the data plane traffic or the data path traffic, how do we correlate that identifier with the identifier in the data path traffic? And that, it's a database essentially within the enforcement device needs that.
Yes. And so regarding that, I've got a quite open and possibly clueless question. Since we are talking about identifying hosts with MAC addresses or IP addresses, are we talking about the cases where, oh, Lorenzo, you're here. I was being you, sorry. So what happens when a host actually changes its MAC address or decide to generate a new privacy address? Is this something we are talking about, or is this?
Well, I think we are, or at the very least with multiple IP addresses, because we are considering the IPv6 case where it's pretty easy to have multiple IP addresses. And Eric had a proposal on the mailing list to deal with that with the session ID, and it's essentially to treat the first session ID user equipment gets as its primary ID, and then sort of linking them together after that fact. Basically, every IP is given a new ID potentially, but then you sort of collapse them back down and maintain that knowledge within the user equipment.
So every time I generate a new address, I will have to do a quick login, quick check to the API to inform the API that I have a new address.
That's, yeah, maybe. I mean, if that's awful, then no, but...
Okay.
So Martin Thompson, maybe I can help clarify a few things. If you change your MAC address, you're a new thing from the perspective of the network, and most networks will not let you continue to participate in the network without doing a complete new reassociation with the network once you change your MAC address.
I can get behind that.
And most devices tend to prefer to maintain the same MAC address over time with the same network, so that for continuity reasons, for other purposes. I don't think we were going to do what Tommy was suggesting in terms of annotating every single packet that we send on there. I think probably the role of something like a session ID in something like this would be to carry information from the enforcement point to the API via the user equipment that contain the information necessary for the enforcement point to later identify traffic that's coming.
Yeah,
So
I see what
we're
you
not,
mean. I see what you mean.
Yeah.
ICMP sends it back.
right. So I send, I'm a user equipment. I send packets out, and the user and the enforcement point sees those packets and identifies. It has some concept of who I am, whether that be the circuit that I'm coming in on, the MAC address that I'm using, an IP address or prefix if we're talking v6. Any one of these concepts it could use to identify me. It decides, it packages that information up into this concept of a session ID and sends that back to me. And now I have a way of talking to other things within that network that allow those things to uniformly identify me. The enforcement point becomes the anchor for the identifier. It mints me a new identifier, and I can use that identifier with all of these other services. And those services can then use that identifier and go back to the enforcement point and talk to the enforcement point based on all of that stuff. And that is, I believe, the architecture that we're describing when we talk about the session ID stuff. And so the question I have is, when we have the three choices, implicit, something like this session ID, and then something explicit, which of the properties of each one of those are we most interested in?
Tommy Polly, Apple. So I get that could work. That's, yes, a lot more reasonable than sending your session ID in every single packet. I don't love having anything like the session ID coming back in the ICMP. One, because it's randomly spoofable. But beyond that, I think as I responded to Kyle and Dave on their architecture document, there's the point of ICMP is a way to tell you you've been blocked, but it is not necessarily the best discovery mechanism. So it's fine for it to say, yes, you were blocked and here's the session ID, but hopefully I've already discovered it and I've already talked to the API server. And if I get the session IDs from the enforcement box, I hopefully haven't talked to it yet. So there's kind of a bootstrapping problem there. Also, so beyond that, like when we talk about a session ID tying together multiple addresses, so we definitely want that to be done. And likely when the enforcement device talks to the API server, it should have some shortened way of communicating about this device. But to the UE, if I'm tying that together, why wouldn't I just say each session ID for each address is the address, or like is the prefix? Because these addresses are already known by the network, right? Like I got it from DHCP, I have my prefix, this is mine. The network, understands that I have it, and so it can just use that as my identifier.
The thing that's on link understands that you have
Yes.
it. Routers multiple hops away do not necessarily know that : : 1 and : 2 are actually the same device.
Which is why I guess that this diagram is like super important. So is the enforcement point or someone who can communicate to the enforcement point on link such that they can do this determination? Because if there's a communication from some router that is on link to someone else, then you don't need explicit.
So I believe that we've had people come up with use cases where you have a NAT in a house between the device, the user equipment that is ultimately making this communication and the enforcement point.
Yep.
In fact, as I understand it, the enforcement point is a long way into their networks because they don't use them particularly often.
Yep.
And so they don't have very many of them. And so that suggests to me that MAC addresses, for instance, would be completely unsuitable.
That's correct, right? And so having a NAT in between this, everything is going to look like the same device. Does this solution work with the captive portal today? Like, isn't everyone going to look like the same device?
Right. Everything in that house will look like.
Right. And that at that point kind of comes to the conclusion that your enforcement point is on link with whatever it thinks it is enforcing. And that may not be the same as your UE, but it views your UE as on link.
Can we distinguish between layer 2 and layer 3 here? I think you're talking about you're seeing the source IP address of the thing that is communicating. But
yes,
even then, I'm not even sure that's true, because I think that the NAT situation is worse than we expected.
So let me try to clarify. I don't know what the answer is, but I think
what we have today is we have two enforcement points. One of them enforces that your IP address, which is visible very far away, but crucially between you and the internet, is the same as a token that is locally visible, which is the MAC address. So you basically pass down, the local enforcement point is on your link, and it can identify you by the MAC address, and is also in a position to force you to use the IP address that it gave you in all communications. So in effect, your identifier is in one part of the network, it's your IPv4 address. In another part of the network, it's your MAC address. But there's an enforcement point that those two are the same. And so they can be used interchangeably. No? Okay.
Okay.
Tell me now.
I'm going to generalize this because microphone's gone funny. Somebody hit the point earlier, and I can't remember who said it, which was the protection device is making its own mind up on how it's classifying your traffic. If it's on link, it could be MAC. If it's remote, it could be IP. It could understand IPv6 addresses. It could do all sorts of stuff. You might be going through a NAT between the two. But at some point, your protection device goes, I don't get this traffic. I don't know. So your ICMP response has to have some piece of identifying information and a place to go to be authorized. So let's call it an opaque token. It's a thing. The ICMP comes back and says, take this token, go to this API server, present that token, and get yourself authorized. And the API server will tell me out of band, you won't see this conversation, that I am then allowed to pass this traffic through. I'm allowed to permit you access. So what goes into that token, how that's mapped in its internal hash tables on the protection device, is the implementations problem. From the API perspective, it's just an opaque blob of stuff. And then we don't have to argue about whether it's layer 2 or layer 3 or whatever. It's whatever the equipment does and is designed to do. Yeah, you have a bootstrapping problem. No, actually, where is the bootstrapping problem?
There's a flaw in your reasoning.
Go for it.
So
the
flaw in your reasoning is if you don't have the two enforcement points that I mentioned, I can take your IP address and I can steal your service. And so that is always enforced. There's always DHCP snooping. There's always enforcement of one MAC address per IP address in today's networks. So there, in pretty much every deployment today, there's one enforcement point here and one there. And so that's why they can use this token interchangeably. Okay.
Yeah, understood. But I don't think my proposal is a flaw. I think my proposal is a generalization of that, where if your protection device is the point of failure, so your protection device is ideally is in a suitable place in your network where people can't spoof MAC addresses and IP to get round and use somebody else's access. So as long as it's installed correctly and is functioning correctly, sure, it might be looking at your MAC, or it might be talking to an upstream protection device and using the IP and having some private conversation there. But between the two of them, they say, here is an ID you need to go take to the API server. And we will compose that. It's not a matter of the ICMP protocol deciding what that ID is defined from. It's just an ID.
One security concern there is, I mean, maybe it's not a big concern, but what if, you have party A and party B. Party A is actually logged in. They're doing their stuff. Good. Party B wants to know if party A is logged in. So they figure out party A's address, token, and just ask the server, is he logged in? Is he logged in? Is he home? Right? Things like that.
Yeah, it's a sensible point, but that comes into how do we generate these tokens? How big are these tokens? How opaque are these tokens?
That means it's not necessarily implementation specific.
yeah.
Right? There's the information that the enforcement device needs, but there's also some security implications that it needs to consider when it generates a token.
Replace the word token with concatenation of MAC and IP address.
Rick, may I ask you a question?
Yeah, sure.
In this model, right? I think what we have here is like we have a three-way communication problem.
Yeah.
And we have to basically start making choices to simplify things so that we can get down to something that, right? And so in my mind, we're looking for choices that are musts so that we can then figure out what else is shoulds, right? So we just eliminate the things that are obviously eliminatable if we can figure out what they are. One of the things in the model where it's address-based, I was trying to sort of figure out what the experience would be for an IPv6 user that's generating new temporary addresses all the time. And if a new temporary address, in your model, a new temporary address could be not identified as being associated with the device, depending on how far away apart the
Okay.
The enforcement point is.
Can I try and answer? I'm making this up on the hoof to start with. Second of all, in my mind, okay, I've got a new IPv6 address, or God forbid I change my Mac for fun. The protection device spots that and goes, hey, I have no idea who you are. Here's a new token. Go authorize yourself with the API server. Go pay again. Well, you, as part of your conversation with the API server, may have a session token, proper session token for I am allowed to use this coffee shop Wi-Fi for 15 minutes. I've bought a coffee. So you can represent that token, say, hey, I've paid already. I've just been told that.
This becomes a requirement for
Yeah.
API.
It's an alternate model.
Tommy. So I agree. I think it's a good point that, the enforcement device, it can have whatever mapping it wants. A couple things with the ICMP sending back a session ID. I mean, the ICMP message also does, it reflects back to me the IP address, the IP packet I sent, right? So like in some ways, the thing that failed is the representation of a key into that dictionary. Because anything that I'm sending to the enforcement device, because I'm not adding my session ID explicitly in to this, the way that they did their lookup into their table is purely just the packet that got sent to them, right? It's a combination of all of the headers. So presumably sending that same information of this packet got blocked to the API would be sufficient for it to do that mapping, no?
There's one potential case where that's not sufficient.
Okay.
And that's where the information is the circuit on which it came in on. So there's a number of cases where you're operating an ISP, you have a DSLAM, and the packet comes in at the DSLAM, and the DSLAM is the enforcement point, and it's the actual piece of wire. And that's not being echoed back in the ICMP. Now,
And is that something that that will have a different captive session then between the two routes into that box? Do we want that to be the case?
I suspect that it would be sufficient for us to say that anything coming in over that wire is the same thing from the perspective of enforcement, and that it would, to the extent that there can be multiple things on the other end of that piece of wire, they're indistinguishable from the perspective of the network operator, and therefore they may not want to distinguish between them. But on the other hand, it could simply take the piece of wire and something else, such as the IP address that was taken, and treat them separately if it wanted to. What Rick's saying is that all of this information is under the control of the enforcement device, and by dictating any one particular identifier, we're pigeonholing in a way that may not allow for particular deployments to actually use this solution. Now, the question that I have is implicit still completely off the table in this model, or do we accept both models? And that's what I kind of want to dig into.
So for your example of,
or we allow both. Maybe not different documents, but we recognize the existence of both as potential.
so for your example of when it comes in off the different wire,
Yeah.
what makes it do that?
Well, I have one wire and you have another wire. Sorry, I'm not
No, but
understanding
so,
the question.
I mean, so I'm sending traffic on my 5 tuple from my MAC address. And so something about,
Comment on a different fiber.
right, so I come in on a certain fiber, right, and that determines how you categorize me. And so presumably that same MAC address and same 5 tuple coming in a different wire would be categorized differently.
Or blocked, which
Or
is
blocked.
usually the case. in
Sure.
these sorts of networks, yes.
So I guess this kind of comes back to when you were saying, like, in your experimentation for the hackathon, like you had issues when the enforcement device and the API had different views of kind of like what link you're coming in. Like, this is kind of another instance of that. So it is possible that potentially, like, if this only works when the API server is kind of on the same fiber as my enforcement device, then they actually, in that case, do have the same view of it. So it depends how similar their setup is.
Yeah. So my question, I think, largely comes down to if we go implicit, what are the constraints on the design that naturally flow on from that. And if we allow for the session identification stuff, what additional things does that gain us? And what additional costs, like the bootstrapping problem you talked about, I think we still need to work through that in the session ID case.
Hey, Ben Schwartz. I don't know too much about all the stuff that's going on here, but it does seem to me that there's a really fun trust problem if you try to use IP addresses as identifiers with all these multiple layers of routers, like especially in the NAT case. You know, if you think that you're permissioning one person behind that NAT, well, no, unless you have a trust relationship with the operator of that NAT, you're permissioning the whole NAT. And that actually goes for all of these routers in this whole multi-layered diagram. Unless you have a trust relationship all the way from the top of that stack to the bottom, you're permissioning the next layer. You're permissioning the last untrusted layer in the stack. And if you do have a trust relationship all the way to the bottom, then well, you know, maybe if there's an operational reason why you can't get the MAC address, but you at least have the relationship. You could get the MAC address.
We do, I mean, later on in my slides, which we don't really need to go to, I do raise the point of NAT versus CGNAT, right? My laptop that's tethered behind a phone is very different than a carrier who's just trying to deal with their crappy IPv4 addresses, right? Like,
We can go through your remaining slides if you want.
I think we're covering all the points I raised.
Sure, okay. All right. Just say if you want to.
So one thing I wanted to say is that so I would assert that with IPv4 we don't have a problem. Does anyone disagree with that?
Yeah.
No?
Yeah.
Okay. Tell me why.
Even with the NAT case?
NAT. I think NAT is the problem.
But like this exists today, and the industry hadn't fallen over and caught fire, and
But we're all here complaining about it.
so for entirely separate reasons.
Yeah, okay.
Okay. So if we qualify that statement and say with IPv4 we don't have a problem, then we can apply the tried and true strategy of saying, well, let's just do it the same way. And I would further propose, like, what if we just said, and I'm being hopeful here. I'm being hopeful that IPv6 prefix per host is going to be published soon. And if we said, look, we're going to define something that works in IPv6 prefix per host, then we can continue to use the address as the token. We just say that this is the prefix. And then we are essentially in the same boat where if you want to block a NAT, you can look at TCP timestamps. And I know you had a bug where you got the timestamp wrong, and they, like, Capport thought you were two devices, and they blocked you. And it was okay. And so if they want to play that game, it's like, oh, you have 3 addresses, and 2 of them are using different TCP timestamps. We're going to block you. That's fine. You know, they can do that. If they don't care, if they care that, like, the primary user of this looked at the Capport page on the screen, maybe we can just do the same thing. And I think at that point, it seems to me that most of the rationale for doing all the session stuff just goes away, right? And so I wonder if we can, like, do that as a simplifying measure, at least initially.
So that you're proposing a set of basically scope limiting assumptions.
Yeah.
Would it be worth spending some time to write a document that calls out the use cases, a few different use cases that might be constrained by this sort of constraint? Like, what are we denying ourselves
But, like,
here?
those use
and
cases,
is it okay?
But these use cases cannot exist today, right? Or don't exist today because in practice it's so much easier to do the IP address-based thing, right?
Or do they exist but in some kludgy, hacky way? I mean, people are pretty clever.
Yeah, so we'd have to figure out what people might be doing that we don't know that they're doing, and, like, figure out why they're not doing IP address-based. Yeah, it's possible.
Okay, it's Rick again. 2 parts. First, a quick answer to, I can tell you what people are doing at the moment. They're trying to make money by making products that are cooler than their competitors' products, that do cleverer protection, to give you a lovely full sense of security and to pay them lots of money. I mean, that's called capitalism. So saying, oh, we just care about the IPv4, then someone will say, oh, but we do cleverer stuff on this, and suddenly it's all broken. So I think we have to have a little bit of a reality check about the people who are selling protection equipment, and I'm sure they're lovely, are trying to make money out of this. You know,
Are you saying we should take a hum on adopting capitalism?
not in public, no. Going to my main point, which was about the implicit versus explicit. The token stuff I'm suggesting, which I see as a superset of take the IPv4 or concatenate it with the incoming wire or the fiber port or whatever you want that's required so that these protection equipment manufacturers can differentiate their products in exciting ways. Yeah. So you take that token only exists so that that 5 tuple plus extra stuff that they care about can be handed to the API server, which may be on a completely different link elsewhere. The token is purely to go and get the explicit session ID. So you've got two things. You've got your token for your traffic that is being classified and has hit the, I don't know, button. And then the session ID you get in response from the API server having presented it, and that one's explicit. So I think the solution to this is 2 tokens. One pretty ephemeral, and one is the one you'll hold for your, yeah, I qualify to have access. And going back to your, they may only be allowed 5 IP addresses.
Or 5 ports.
Or 5 ports, or 5 whatever, 5 magic beans. The API server is the one that's counting, because the client just gets handed a token. The client takes that token, presents it to the API server, and the API server has to decide if it has to talk to the protection device in order to do that, or a whole suite of protection devices. That's a whole different API, and I think that's out of scope for this.
So are you suggesting that the initial login
Yeah.
gets you your real token, your real session ID, or if you will?
Shall I play it through?
And okay, sure.
Yeah. So I'm a user, piece of user equipment. I wish to access the thing, the internet. The protection device goes, I have no idea who you are. I have examined your traffic and decided I don't like you. So ICMP response comes back saying, take this token, present it to this API server. So I present that token to the API server over some protocol. And the API server goes, great, you have permission to access the network. Here is a different session token. So this is your session ID. You hold that.
And this one gets you to Yahoo?
This gets you to whatever the system has been set up to let you get to. So if you go through the web page and sign your children away and all that kind of stuff, whatever needs to happen, you get handed a session ID. You don't have to present that to anyone anywhere. You just hold that. If you change your IP address, you change your MAC address, you come in on a different fiber, whatever, ICMP comes back, says, don't know who you are, here's a token, new token. Go present it to the API server, and you go back to the API server and say, it's still me. Here's the session ID you gave me earlier. And the API server can decide whether you're allowed to go in as this new token or not, or do whatever clever stuff it wants. So it's a 2-part exchange.
How do you make sure that you're talking to the right API server? I mean, or I guess there's a question of like,
That's a different question. Do you trust the response?
You don't want someone snooping your session IDs, right? I mean,
Pierre Pister, I'm not sure I would like a new transaction to happen every time there is a new address or so. And it's really desirable that a host would be able to use multiple addresses. And so I kind of agree with Lorenzo that one good way to do that is with prefix per host. And in the end, in terms of security, the only way I see that would work would be with an enforcement point, not only on the link L2 speaking, but on the wire or in terms of Wi-Fi, the virtual wire, where you really need something that is able to bind the client to what port it's connected to on the first op device that is enforcing and binding the device. Is that clear enough? So because we can't tag packets, we can't secure the packets themselves.
You're saying you want the architecture that we propose discussing should have a requirement about implementations having like on-link properties.
I think we cannot,
on-link control.
in terms of security, any model that relies on layer 3 security doesn't work. Any model that relies on layer 2 security doesn't work because the MAC address can be spoofed. We cannot make generalization about the security of the layer 2. So the only thing we can say is that we need something that is kind of secure, like wire, physical wire, or Wi-Fi that is able to discriminate between multiple clients connected. And once one client on one port or virtual port is connected, that becomes the identity. That's the port or virtual port becomes the identity. And so that guy is connected, and that guy can have a full prefix or multiple addresses, and we don't need to do a new negotiation every time there is a new address.
one thing I would maybe want to clarify there is, I don't want to preclude future lower layer implementations of security, right? For example, right now with Wi-Fi, I can spoof someone else's MAC address. I can spoof someone else's IP address.
You sure you can do that on a secure Wi-Fi?
Well, maybe not secure Wi-Fi. So this is the thing. Like, there are things that at the lower layer which might help you, or maybe. I mean, rather than just say it must be this port, we just say from end to end.
Well, there is a kind of security handshake between you and the AP that gives you an identity. That's what I call the virtual port. It's I don't know the Wi-Fi term for that, but there is an association.
Okay.
Association. Yeah, there is people.
So, Mukesh Agarwal, work for Google Android Wi-Fi. So the association is, as far as I know, right? If it's an open network, the AP is going to have some state with things like buffers, right? And so if you somehow tie to the buffer state, then sure, you could say there's some kind of strong association even for open Wi-Fi. But I think without going to that, it really is just the MAC address, right? Now, if you have like a WPA2 network, then you've got the pairwise encryption key, right? And so you can protect against spoofing with that. But I think on an open network, it's a difficult.
Say something about opportunistic.
Oh, okay. So there is this proposal from Warren for opportunistic wireless encryption, where they bootstrap the pairwise encryption key even on an open network.
And what are the security properties of that?
Let's see. So
But can you guarantee? But can you guarantee like stability? So it's like someone authenticated if it's the same person who sent originally on this file? Yes. That's good for this.
That's okay then.
What you want.
Can someone repeat this discussion into the mic?
Please.
I
Dan,
don't
do
know
you
you
wanna jump
understood.
in
Yeah,
on OWE?
come in and.
It's RFC 8110 OWE, and it basically does Diffie-Hellman in the associate request response in .11. So .11 is a state machine. When you go from nothing to associated, you go through these steps, and it does
So I think the
create
key
state.
point was that it doesn't prevent necessarily snooping, but it does.
It does prevent snooping.
Oh, okay, it does. But
It does prevent
but I think the key property we want is that it verifies the identity of the sender.
Well, so there's no authentication. They don't know really who the identity is, but you'll have a you'll have a guarantee that if you received a frame that's encrypted by the claimed sender, that he really did send it.
Right.
You don't know who he is, but you know that nobody else could have spoofed that frame.
Can I as a client user or spoof your Mac? No.
No.
For some period of time.
No. So what you could do though is if you used my Mac and you tried to associate to the AP, the AP will go, oh, he must be confused. I'll throw away that old state and now I'll do OWE with you, and then probably.
At that point, the AP knows that the encryption state has changed and it can be guarded.
It can
Yes.
charge you again. Or it can charge you
Yes,
again.
yes, it'll throw away all the state if it so chose to do that. Yes.
So Pierre, I just wanted to say that I think that you're binding on the port. Again, like I said, if you have two enforcement points, you can just base that on the IP address, which is I think what we do today. So basically enforce locally that the prefix that I got is tied to a MAC address, and then later on that prefix is enforced. I just wanted to say though, we can use extension headers to pass the tuple along.
Let me just interject then with a time check. I think we have about 45 minutes to an hour left. We have 2 more presentations for which we've allotted like 15 minutes, normally including questions. So we have maybe 15, 20, up to 30 minutes at most for this discussion. And we should probably just cap it at 15 so we can ask some questions of the room to see what decisions, if any, we've made.
Should we guide the remainder of the discussion, do you think, or still keep it open?
I think maybe we should drain the queue of comments so people don't forget what's in their head at the moment, and then we'll attempt to ask some questions.
Ben Schwartz. So I think maybe the session ID term is confusing. And it might be a little bit clearer to call it equipment ID, maybe. It's an identifier for the piece of equipment from the perspective of the enforcement device.
It's a traffic identifier, and the work is to try to coordinate the traffic identifier with some kind of user endpoint, I think,
Why
right?
not client ID? Sorry. Why is it not a
Client ID.
Client ID.
And I also I understand there's more depth here than I know about, but I think it might be a little bit clearer to say that this is something that you get in DHCP, or at least something that you could get in DHCP, because the point is that it has nothing to do with activity on the part of the user. It's all to do with the enforcement device's view of the user, and that's stable from the point that the user joins the network. So that
When
can
you
be.
say, when you say DHCP, you mean network attached.
I mean, at network
Alright.
attachment time, it has nothing to do with some future point. And so there's actually no need for this to append anything, to include any metadata in this access denied ICMP response.
If the enforcement device is elsewhere in the network, where it may not be able to communicate with the DHCP server, or is that a
So
thing?
if the enforcement device is farther away in the network, then the best identifier it has for the client, its client ID, is going to be whatever it can associate with the client. That's going to depend whether it can cooperate with the nearest NAT, whether it can cooperate with that access point that knows the association ID. But all of that is, it seems like that's all knowable at attachment time.
Okay. Tommy, yeah, I very much agree with bringing up the attachment time as an important thing here. I agree with what Lorenzo was saying. Essentially, like, we can just kind of use either something, like, if it's something that we get in a DHCP or RA, I'm fine with that. I think we could also just kind of use our addresses and prefixes, because that seems kind of equivalent at that point. So if there are multiple hops between us, and if the enforcement device is quite far away, either there's going to be kind of like a uniform deterministic path that all my traffic is going to take, like it's just going to go from whatever API I am on link to, and like my only way from that link to the internet is this captive portal, or else I have some other way to get around it. And if I have some other weird way to get around it, or I can come in off of multiple wires or something, that feels like it's not really a very good enforcement box for whatever link I have. So to some degree, it can collapse, and hopefully, like, you could set up your network in such a way that you'd be able to get the information necessary to say this is a controlled path. Because if it's not a controlled path in which we can say deterministically that we're going to come in on the same wire from your AP with that IP address to the enforcement box, you're not really able to enforce much with it. Yeah, so I would just say, yes, let's write down the constraints that this produces. But I think if we're trying to do more of a session token, it adds a lot of complexity, and it's not really clear what use case that we want to happen in a deployment we're actually enabling.
I'm wondering about the case where the enforcement device may not be actually enforcing whether or not traffic's allowed in the normal case, but is denying access when a certain event occurs. So, for example, you're infected with a virus, and the ISP said, "Nope, you're blocked now. Go away." I just want to make sure that we still support that use case, because I've had a couple of vendors talk to me and say they want this use case, or sorry, ISPs talk to me and say, "I want this use case to be satisfied by the architecture."
Yeah. So Martin Thompson, I think I've been relatively convinced by the discussion about the fact that the enforcement device needs to have some sort of stable identification for the thing, and needs to be relatively certain about that identification. So you cannot rely on things that might change across the various paths. I think it reads to me like the group is fairly solid on that point. I think the one use case that Rick's sort of strong suggestion that we do this sort of opaque session ID thing has would be, sorry, let me back up. The idea of adding some sort of explicit identification to the rejection coming back would enable one use case that we haven't really covered particularly well, which is a different deployment topology for the API server. That API server does not necessarily need to sit on the same in approximately the same location as the enforcement device in that case, because it can rely on, say, cryptographic protections on that opaque identifier to transitively, basically to look from the perspective of the enforcement device by virtue of receiving that thing. So
Why is session ID necessary for that? You state.
Because when I as the user equipment go out to the API, I'm going to ask it a question. Am I captive? And it needs to have the same perspective as the enforcement device when it answers that question.
But your IP address might not be spoofable, for example.
But if
So it doesn't have to be.
But it's a different path.
It doesn't matter
But-
as long as you enforce it at the ingress.
Well, what if you have two connections, right? I have a connection to the internet and a connection to, over over my cell phone, and LTE versus Wi-Fi. And it happens that my device decides to go out LTE instead of Wi-Fi to talk to the API server.
Yeah. So that's one particular deployment topology that would be enabled by this. Now, I think to Lorenzo's point here, yes, if you're using an IP address and the IP address is not spoofable to the enforcement device and not spoofable to the API device, you're effectively saying that they're more or less in the same part of the network. And so if you're willing to accept that constraint, and I don't know whether we are willing to accept that. Rick's shaking his head and saying, "Well, that sounds."
I think
we can document that as a consideration, but I would like to hear, probably not here, because I think we're reaching the end of this discussion and reaching the point where we won't get any more useful output from this discussion. But I would like to have someone write down the limitations of this sort of what I would call the implicit identification thing that we talked about originally, and then talk about some of the limitations of the sort of session ID transiting the information via the UE, and explore those, decide whether or not we want to do both of them, decide whether we want to do only one of them. And I think that would give us a pretty good way forward. I don't think I'm seeing much call for people putting explicit IP addresses or anything in these messages or anything like that. I didn't hear any of that. So we can probably scratch that one, which to me would be a win. And then it's probably up to folks like Kyle to actually do the legwork. Does that sound like a reasonable summation of the position we kind of reached in that discussion?
It seemed like the sort of active session ID, client ID stuff was not terribly in favor. The sort of it's done for you by other elements of the network, or it is your address somehow, or is a feature of your attachment time. Seemed to have more positive discussion surrounding it.
So as we're listing kind of the constraints on both sides, one thing that I'd like to hear from the difference between the session ID. So we brought up this case of the API not being kind of co-located on the same link or the same path. And so I see that, I mean, maybe that's a problematic thing that we're adding a constraint to. You could, let's say if you don't have a session ID, explicitly send, here's the packet that I would have sent to the enforcement device. Here's my MAC address, here's my IP addresses, etc. And so that's kind of like a token. And so what's the problem with that? You could just say spoof it. It could be whatever you want. I don't actually see how there's any difference between that and the security between this token that I get back for my session. Because let's say I, on my phone, talk to the enforcement device or talk to the network. Hopefully I don't have to get ICMP just to realize I'm captive. But if I do, I get this session ID back, and then I have to talk to the API server that's somewhere else. Cool, now I have the session ID that lets me get to this other entity on the internet and get in. I can now give it to all my other devices. And in the same way that all my other devices can spoof, it's a slightly harder thing to construct, but I can just advertise this to the entire world, and now everyone in the world can act as if they're my session ID. So the only way to fix that is to have, again, the API server in a place where it can say you're on that network.
If it were the HMAC of your L2 to L4 header, for example, your keyed hash of your L2 to L4, L2, L3, and L4 headers, then you wouldn't be able to spoof it without knowing what the key in the HMAC is, right?
Yeah, that's the point.
Wait, so this is not just a token that I send over. What is being signed?
So I think I can answer that.
Yeah,
so Rick's model has two identifiers. One is explicitly an identifier that goes from the enforcement device to the API server, and that identifier uniquely identifies
The traffic.
the way that the traffic, the way the packet arrives.
And this is just a blob.
And that would
Yeah.
just be an opaque blob that carries, say, an IP address, MAC address, circuit ID, all that sort of stuff.
Based on the medium.
The other identifier that he's talking about is a database key, for instance, that says, this is Rick, or my understanding of Rick,
And bought a coffee.
and he's bought a coffee, so he's allowed in. And it would have a number of the other identifiers listed against that, such that the API server, when it decides to let Rick use the network, can go to the enforcement device and say, if you see X, let it through. If you see Y, let it through. You can't give that identifier to someone else because you're not originating traffic that meets the profile of Rick's traffic.
To spoof me, you have to spoof all my traffic as well.
Sure. So I'm not saying that I can spoof and actually get access to the captive portal. I'm just saying that anyone could interact with the captive portal API and potentially find out how much time I have left, query it, pay on my behalf. So there's right and to that end, if all what I do is just send my IP address and MAC address on this link to the captive portal API server wherever it is, then it just says, hey, enforcement, only whitelist that. So no one else can still spoof me. Like, it actually hasn't gotten me any new security property.
Yeah.
I mean, well, the one security property is it hides your identity from the API server.
But the API, okay.
Well, yeah.
The API server is going to know who I am.
You're probably paying with your credit card anyway, right? Like, I mean.
But in my mind, your token may just be your IP address. So we're talking about the same thing. So I don't see why my model's broken, yours isn't. The reason we're calling it a token is it could be more than just an IPv4 address. Yeah, in common case, an IPv4 address works because they will do it.
I see anti-value. I know anti-value. So I think we had a while ago. There's a pretty strong statement that we did not want to be able to facilitate differential treatment on the basis of destinations. Okay, so I would argue, and maybe I'm wrong, but in first instance, I would argue that that means that your token cannot change and you can't get a new token. Because if I have to ask for permission from the network to get a new token, then that means, well, if you want to get to Facebook, here's a token. But if you want to go to Yahoo, you have to pay me another $2. And I think we decided that we did not want to do that. And I don't know, I don't think we put that in a charter, but I think we had strong statements that we didn't want to do it.
We had strong statements. I don't think we officially agreed to that. But does anyone disagree with that sort of general viewpoint? Rick, I think I saw you nodding there, and I want to make sure that I get the words
I'm
down.
not disagreeing,
Yeah.
but I can see how it will be abused. I can off the top of my head, and I'm not going to say it on the mic because I don't want people to work it out, but I think I can see a way of abusing that for fun. If I was an evil ISP.
So we didn't want
And I just don't want to discuss it. So I don't think it's secure enough to avoid it by saying, oh, it must be an IP. I think there's still great gaping holes in it. But I agree that we shouldn't be differentiating on destination and, you know.
And my point was, therefore, if we made the token intentionally static, we would at least not be facilitating such abuse. And we would, in fact, be designing a system that was clearly not intended. Now, whether it's not intended and whether it's secure against abuse, it's different things. But I mean, I think then if it's not intended for abuse, then we're not going to have a difficult time later on securing it because we know what we built, right? So even if we don't secure it immediately, then we know that, well, this is the way it's designed. This is the architecture.
Thank you. Thank you all. Kyle?
Did you follow that?
Were you taking notes? Mental notes?
We'll see. Depends on how bad that jet lag is right now and whether I'm actually awake or, zombie mode.
Would somebody be willing to write up a summary of, or send some thoughts about active versus passive to the list?
Yes.
Because we should absolutely capture this and begin to form some text and.
Could the Etherpad check over the attribution? Because I don't know
Ben Schwartz. I just, on the topic of abuse, I just want to emphasize again that if this is, however the token is constructed, if it's something that you do at network association time once, rather than something that comes back in an ICMP packet, then I don't think it matters how the token is constructed.
One thing I was thinking about with respect to association time, or attached time, whatever we're calling it. Is it unreasonable? Supposing we do have the API server somewhere out, across the world, is it unreasonable to expect a feed of identification to correlate things together somehow? I don't like. Does that even make sense? Maybe not. I'm not sure. You would anyway. Something we could think about.
So I'd like to make sure that we have someone on the hook for this. If you, with the assistance of the minutes, look into this, do you think you could provide a short description of the two things that we discussed here? I mean, the minutes will be great. I'm told they're awesome, but that will contain a level of detail that I think most people will be unwilling to spend the time to wade through. But do you think you could do a couple of paragraphs on each and sort of,
Sure.
We rejected this, but we looked at the following two options, and here's kind of maybe even a proposal of where you think we should be heading.
Sure, I do that. Thank you. Are you how are you doing? Are you ready for round two? I think so. All right, what am I talking about now? Right, the architecture document. So this is pretty short. So I can get out of your faces soon. Thanks for Dave Dolson for putting this together. He did all the slides I'm presenting. Yeah, so updates. We adopted the draft. Yay. So now the working group will take it forward. We've had some feedback since Prague, pretty much exclusive from Tommy Polly. Thank you. It was great. We've already incorporated some of that for more minor issues into the Git repo. Haven't uploaded the draft to Data Tracker, but that'll come soon. The remainder of the presentation is going to be talking about some of the major issues that Tommy raised. All right, so most of them are related to PVD versus DHCP. And so I think we kind of need to decide as a working group whether DHCP or RFC 7710 is good enough. Does it have all the properties we need? And if it doesn't, should we update it? Or is it just better to just use PVD and define what we need in the PVD draft and take that forward and then obsolete RFC 7710? So that pretty much, yeah, next slide. So I think some of the issues that were identified with RFC 7710 were the question of whether or not it's providing an API endpoint or a login page. The other issue that was raised is that it doesn't give you an explicit indication of whether or not you're actually behind a captive portal, which is something that could be desirable. And we could do with PVD. Sorry, these slides are a bit out of order, but all right, next slide. And yeah, that's what this is. So I guess it's probably a question we want to ask. I don't know if we want to hum on it or not, but do we want to, should I just ask, do we want to deprecate RFC 7710 and remove it from the architecture and just ignore it? Or should we reopen it and extend it? Or is that just an inappropriate question?
I think we'd want to know on the extended or replace it, like, what are we replacing it with first? Like, I mean, I would love that to be PVD stuff, but I guess we could. I guess
we need more discussion on what the characteristics of a good provisioning service is.
I think we need to talk more about essentially captive portal discovery. I guess I think the only thing we have enough information right now for is to say, do we think that 7710 alone is insufficient? Because I think that's the one thing I've heard being relatively clear, that it either needs to be updated or replaced, but we should discuss more at length the nature of that update.
I agree with that. All right, so maybe there isn't room for hum here, but
I don't know. What do you think? There's a GitHub issue to this.
So I think the only deficiency, I mean, there is a deficiency in 7710 that it says, it doesn't say
what it is, right? But you know, we can say that, and we can say, you know, if you, I mean, I don't know of any existing implementation. You can say basically, if you use this content type or this accepts header, then you get like the API server, and that's a poor man's version of PVD. I mean,
I was also thinking of just an empty string being there is no captive portal. Maybe that's crazy.
Isn't that the evil bit? It's sort of like, yeah, there's no captive portal here. It's like, really? Right. So,
I thought the document, it doesn't say what to do explicitly, but it seemed to be designed such that implicitly it was the web endpoint from which you begin your travails.
right, but like given the absence of implementations, it would be easy to say, well, we can just update that document and say, ask a question with this accepts header, and then you will get the API or something. So now we're going to do the PVD download anyway. You know, given that we don't have an implementation, it's a lot easier to do only once the work of getting the kernel to pass you up the PVD sequence number instead of passing this one up every time and like modifying the DHCP client. It does work for V4. This, I don't know what the PVD stuff. Yeah. Okay.
Rick Taylor again. I have a slight problem with 7710, always have done, which is it's kind of designed to make the web work and not the internet. So whether it's a 7710 base or we look at the PVD stuff, which I must admit I'm less familiar with, don't really care, but I would love to see addressing more than just the web.
Can I ask you, how does PVD strike you as a possible implementer?
It looks like something I should go and read better, because I'm going to qualify my
You have about 10 minutes. Okay.
All right, next slide. And then the final issue that we opened is basically the discussion we just had. So clearly not a minor one. And so, yeah, we need to clearly address this. And that's it for the update.
So I'm going to expect that we're going to get something in the next few weeks about this. And then I hope that the people here will provide their feedback on that. And we will try to make a decision on list before the next meeting. If this doesn't happen, we'll be organizing a call of those people interested. So I've no interest in having the next meeting occur without a decision on this particular point. It would be good if we could take the discussion on 7710 a little further. I am not averse to producing a document from this working group. Speaking, our area director may disagree, but I would talk to our area director and try to convince him that producing a document that obsoleted 7710 by improving it in some way or other would be a reasonable thing if the working group decided that was a good idea. But Adam can speak to that.
Right. So I was actually just considering, I need to coordinate with probably Warren about whether that's something that, is Warren in the room, by the way? I know he's like working on the
Warren would
document.
love to be in the room, but he can never make this because there's a bunch of ops stuff that he has to look after.
Okay. Yeah. So I'll have to talk to him about whether that's something that he thinks is reasonable. I don't think, I'd have to read it very carefully, but I don't think the charter currently includes that, but I wouldn't
it does not.
necessarily be averse to adding that if it's something that we think is necessary for success.
Yes.
And if it's something that the ops folks thinks is a reason that ops folks think is reasonable to do.
Correct. And I would make sure that we get all those people involved, and we need to be certain that we're not making changes that would be destructive to existing uses of that.
Right.
Well, in
I-
this room, I'm fairly confident that it's not being used, but
Well,
That's only these people.
I heard this as being enhancements as opposed to like throwing stuff out. So I don't.
yes, clarifications mainly.
Right.
And this is an acknowledged weak point on 7710, which is that it never actually said what this URI points at, which is just flabbergasting. But nonetheless.
Okay. So you, me, Warren, we'll get together and talk about it.
We can talk about it, but I think first we want to decide here whether or not we want to take that on, and whether we identify the shortcomings and see whether or not we want to take it on. That being an explicit signal that you're not captive, or that there isn't a captive portal, I will say, and the clarification of what it means to go to the URI.
Thanks.
I think those are minor things. Yep.
For the previous slide, when you say you want a decision on that point, I think I'm gonna say that we could. I'm gonna say that we need the combination of MAC and IP, like combination of MAC and IP for IPv6, with enforcement happening 2 different points, which presumably could be something else, but it's. Yeah, I would like that to be one of the options that we decide on. Because does that make sense?
Those are all properties of the attached time too, right? Which is nice.
Yeah.
These microphones. Hello, everyone. All right, so I've been up with the mic already, but I'm Tommy. Among other things, I'm one of the co-authors of the PVD document. So this is provisioning domains, how to explicitly discover provisioning domains. Provisioning domains came out of MIF. They help you discover properties of your network, and this is all about the explicit stuff. So the document that we are working on is now adopted in int area. That has been submitted, so you can go read the new and shiny draft IETF int area provisioning domains. So there are a number of editorial changes made there. Among other things, in the privacy considerations, it is kind of captive portals has been re-added back in as an explicit thing that's been called out in the document, as it has a side effect, because essentially when we are doing the PVD attachment, because this is a network attached thing, we are not actually having to create any traffic on the network that is showing kind of what we were trying to access first, before we have done some negotiation to figure out, do we even want to connect to this network? So again, the PVD approach is really all about how we're getting the discovery of the captive portal based on things we can do at attached time. A lot of implementations, iOS, Android, are in some sort of state in which you don't want to really be using your network until you know you are not captive. So doing something that doesn't rely on throwaway probes is very useful for this. So, yep, so the document's going well, going ahead. Next slide. Okay, so here's the pitch for why we should use PVDs for captive portal discovery in here. I mean, clearly, I'm fine if we also take 7.7.10 and try to update it to do the equivalent things. From a practical standpoint, because I believe the PVD work is important and useful and is kind of fulfilling the same role, I'd like to see our kernels changed once so that we can get this information up. That would be a very nice thing to do. And I think there are going to be other beneficial properties that we're going to get from PVDs long-term in here. So yes, as we've been saying, 7.7.10, something needs to be done with it. As long as we're going to do something with it, can we take it further? So the way that this works is a PVD, the PVD information. So I get a PVD identifier coming down to me in an array. It says, here's the kind of the long-lived static information that you can go fetch as its API. That long-lived static information can point to your captive API server or whatever that is. So essentially we would add a key in there in the PVD to say this is your captive server. If we have future other captive methods that may be more geared towards IoT devices, things that maybe have different ways of interacting or are not truly captive, and that's still a property of the network, that could also go here and hopefully would be easier to extend than adding more DHCP and RA options, because it's a little bit more flexible of a dictionary. And a key thing of this also is that because we are using arrays for this, if your overall network configuration changes at some point, it can push you a new array, and here's your new generation count of your PVD. You fetch it again, you realize that there's now a new law enforcement in town. So yeah, we have the side effect of, if we're doing PVDs, I would like to say in a PVD network that we add into the PVD spec, if you are doing captive, you better put the captive pointer in here. And if you're not doing captive, then if you give PVDs otherwise, we assume that you're not giving a captive network. Of course, you can still be evil, you can still block traffic, but then the devices can feel free to be evil or not join your network back. So there's also the question of, how does this deal with V4? I'd love if we all had dual stack networks everywhere or V6 support everywhere. So one option is that even on these V4 only networks, you can still send an RA and you don't ever give them a V6 address or a V6 prefix or a route, but they can still get the information that way. And then you still have your pointer over to your PVD server. So that's an option. All right, next slide. So here are just some open discussion questions and we can talk about these. So one thing is that this solution does add a little layer of indirection. It's not necessarily too terrible because this is something that you're probably going to fetch anyway the moment you attach. It's just kind of like one little extra round trip. So in that regard, it's a very small little bump, but it does create a less direct lookup. So that bothered me a little bit, but I think I'm okay with it. There are benefits, however. We can fit more into a PVD JSON API than you would be able to have in DHCP RI options due to packet size limitations. So if we want future extensions, this may be a easier way to essentially roll this out. Like we do the work of modifying our RAs or routers once, and then we can much more easily drop these keys in to extend functionality for new devices, smaller devices, things that don't have browsers. The PVD lookup is sent over TLS, so there's some level of encryption, privacy, not necessarily client authentication or anything like that, but it's better than just dumping out everything that's going on between these two devices. So if we wanted to put more private session tokens or something, it's a better avenue for that. Yeah, and there's more flexibility to pointing for other things. Great. So that's kind of where I am on that. If people have opinions and thinking this is a non-helpful layer of indirection, I'd love to hear that and we can discuss. So another discussion that I was having with some people at the hackathon when we were kind of brainstorming about captive portals is when we want to publish a captive API document, and this is essentially, here's your dynamic JSON that you interact with to say, am I still captive? How much time do I have? Where do I go to pay you money? Terrible things like that. One question I have is that a truly just captive API and this RFC this is just for captive stuff? Or do we view this potentially as here's mechanisms for interacting with a more dynamic per device kind of subset of properties, such that if we had other similar cases that weren't the traditional captive network, we would put it there. That's an open question. In that regard, you could almost view it as a, we're talking about like the yin and yang of you have your static side of a PVD, which changes on a generation count, and that's your network configuration, and it can point to one or more dynamic objects, captive being one of those, and being the primary one right now, but potentially on other situations like we were talking about, a carrier network that starts, saying your plan is gone, and so you can go ask other information on a more per device level. So that's more about a terminology question, how we talk about things going forward, but it could be interesting. And then lastly, so I think we believe the PVD authors that dropping in a pointer to how you get to captive makes a lot of sense. If we do that, where does that live in a document? Does that belong in the main PVD document? Does that belong in a Capport document, potentially in the API document saying here's how you get to it from here? That is a question that would need to be worked out as well. So I think that's all I have. If there are any questions, I'd love to hear discussion. I think today we've been mainly trying to nail down this identifier thing. That is very important, but there's also the looming question of how are we discovering these things, and we just need to make up our minds. So any pros and cons, I'd love to hear.
So Michael Abramson, just on the V4, one reason for not deploying a V6 is because you don't have first hop security for V6. So you might just block the Ether type or something like that to not have V6 at all to do abuse handling. So then to tell them that they need to deploy RAs in order to do PVD announcements for V4 only, that might be hard for some network.
That's a good point.
Yeah, now when you use RAs on a V6 only network, someone's going to tell you that now
in a V4 only network.
So yeah, then someone's going to tell you that a rogue device can send the RA, and so now everyone has to deploy RA guard on legacy infrastructure that's never going to be changed. So it's non-trivial. I on the
Just specify that all captive portals have to be dual stack now.
yeah, sure, that's going to be great. So I'm not convinced that the evil bit is going to help. Maybe it will, and maybe it doesn't matter. But
I don't think it will stop people from being evil. All I want to have is to make it possible to be good. And right now it is not. Right now, every time I join a network, I have to send a probe to something, either to something that the user really wanted to get to, or something that gives away the fact that I am an Apple device or an Android device running this particular version of the operating system, because here's the probe that it sends out.
You just need to change them more frequently. Sorry. Okay. Like I said, but I don't. And, if we sure, I don't think it'll be a benefit, but I don't think it's harmful. One thing that I wanted to say about the let's see. So the whether we should have sub PVDs on a per device basis, I'm anxious not to. So in order to rev those, how do you rev them? Do you send a multicast array with a new sequence number?
Right. So that's, I think Captive has a really clean solution to this, because the failure case, the timeout case of Captive information is you get blocked and you get ICMP back.
So
and
that's better than that. Yeah.
That's beautiful, right? So ideally, like I would say in my ideal case, I get my PVD, it says you're captive. I talk to my Captive server. It tells me you're logged in, you have this much time, and then I can re-up it or do something before I get blocked. But if something changes, we get ICMP. So that solves itself. But there may be things in the future that want to do pushes.
Right, but I think my point really was that doing something. So I think the main method you have here is a push method, which is essentially a multicast push, really, because RAs are kind of multicast push.
Right, and so it's saying the entire network has changed. We have a new captive portal entirely.
Everybody on the network.
Yes, it has to go to the new portal because it's a new sheriff's in town. Yeah.
So if you go to the slide 3, I believe, my answer to that one is like, we want something that's not, we don't want to send a new RA when one device's captive portal closes.
Absolutely. No, so essentially what I'm saying is I'm recognizing the captive portal is this separate dynamic thing that hangs off of it. It has a very nice solution in ICMP. I'm just musing aloud that we may have other things that need to be dynamically updated, and they may not have the crutch of ICMP to fall back on.
And I'm going to say that we shouldn't be using per device. So yes, if they're network-wide things, yes, we can use arrays, but we shouldn't use arrays on like, oh, your sub PVD has changed, therefore I'm going to send either you a new array, which means that the router has to keep a lot of state, or I'm going to send everyone a new array, which means that everyone drops them.
Right. So yeah, I would not propose that. Like, if anything, you could imagine that if we had this category of dynamic sub APIs that we talk to, like the captive portal API, maybe something in that API could define some other push mechanism just for you, right?
And yeah, then we have to say is one way to do it. You must have an up. If you wanted, like my assertion would be, if we want to support like sub PVD APIs, you must have a push mechanism that is not the RA.
Yes, absolutely.
In which case,
which is a good thing to specify in main PVD. Essentially, yeah, just to really reiterate that.
Rick Taylor again. One quick question. The Question. Several people have raised the point with IPv4 only networks and requiring RAs on IPv4, which I agree is it's just not going to take off.
Yeah.
They're just not going to do it. So is it possible? Would one way forward be to look at doing a 7710 bis to just handle the IPv4 case? Just say, yeah, PVDs, this is the way forwards. It's all built on RAs. In your dual stack and all your new stuff, it's great. Go this way, guys. But
That's
for
one
those
way
of
to
you
do
who
it.
are determined to stick with V4, do a quick rev of 7710 just to iron out a couple of little things and say, you know, this is a minimal base. It's a thought.
Yeah, and you can imagine even in that document, in that update, it defines the way you drop in the captive portal API URL into the PVD.
Yeah. You could sort of tie them together in some way.
Was there IPR?
Not for captive portal. In
Right,
DHCP.
but if you're putting a PVD ID in
No, you're not.
DHCP
No,
Oh, it's
you're
not.
just putting, yeah.
Yeah, there may already be a PVD ID in DHCP.
No.
It was,
Go look
there
at-
was IPR.
That was
Don't
IPR.
ask.
Oh, okay. There may already be an RFC, is my point, but we can talk privately.
Yeah. Cool. So, I mean, I think the first order of business for the group is to kind of follow up on the main identifier stuff, but I would like to have kind of also at the same time convergence and discussion on the discovery aspects. So, I think the main thing that I want to take back as an action item is the V4 only case and just make up our minds. And then we'll send it out and say, does this look good to everyone? Yes or no? Great.
Thank you. So we have nominally 20 minutes left. We had quite the discussion. Thank you. Thank you all. That's much better than the sort of what we were trying to have on the list. So it was very good. I had, let's see, random questions. How many people here have read the ICMP draft? Most people. Okay. So you know that it has two portions, right? It's got sort of one half that defines a new destination unreachable subcode, and then it's got the second half, which defines an entirely new capture portal code point and a bunch of extension information. New message, right? And it was in fact from the letter that the whole session ID discussion was came from. I think that no, the destination unreachable was just a new subcode to let you know it was captive portal and not network unreachable or something, or port unreachable. No.
Isn't it already? I think it just uses the existing one.
So my understanding is that there's destination unreachable with an extension.
Yeah.
And the extension carries, I think, some of these extra parameters, like this session ID that we've talked about. And so I think we're going to wait for a little more discussion about the implications of session IDs versus not having session IDs on the list once we've seen more of a summary and had some time to think about them. So that will determine the fate of ICMP to that extent. But we'd like to get an idea of whether people are interested in the part one of the ICMP thing, and then whether people are interested in the part two. And we haven't talked a lot about part two in this room, but we saw that a large number of people had actually read the document. My understanding of the use cases behind part two is to provide things like advanced warning of captive portal enforcement coming down. So 5 minutes ahead of things, it'll say, you have 5 minutes remaining. That sort of level of notice. It was an information channel. And that seemed a little, I'll let people speak to that, but that seemed a little less certain from my read of people's feedback on that one. Tell me.
So I'm just looking at the document now to kind of figure out what the options we have are. So as it says in the very beginning of the document, one option, the do nothing option would be send unreachable with administratively prohibited, which I believe is, when we were doing hackathon stuff, actually the code that was being sent. So that's the do nothing option, but still prescribe that you should send it for captive portals. 2, I think what you were referring to was essentially say we get a new code for captive portals, but we essentially still use ICMP in the similar mechanism of I'm just saying you're blocked. You're blocked.
You can provide extensions to the admin prohibited as well. That would be
Sure.
in that.
All right, is that the third
options.
case or?
Destination unreachable contains some codes that are exploited.
If you
Yes.
do the 4884
Right.
thing, you can do that. I don't know how widely implemented 4884 is,
Mhm.
but it's possible.
Mhm.
So we could define a new code point or not. We could define a session ID extension or not.
Right. So you could either use existing with administratively prohibited as the reason code. You could have a new reason code, or you could have the full blown extension. Are kind of the 3 options I see.
So from what I remember with some discussions I had with David Bird in Chicago, one of the reasons or advantages of having the new extension or the new ICMP type was that it would be ignored by devices which don't understand it. And the problem is if you were to send a destination unreachable for a just to say, hey, you're about to expire, you'd actually end up blocking the traffic that you're responding to. And that could be problematic because you don't want to interrupt that flow. Whereas with the new one, you can send it and it won't actually cause anything if you don't understand it. So, I mean, I'm not sure if if that use case of notification when a change is pending is important enough to warrant this, but I think that was one of the main reasons behind it.
So I don't know why this never occurred to me before, but like close to 100% of captive portals are open Wi-Fi networks where the attacker is always on path. And so ICMP is like at best like a DOS vector, right? Like anyone, like literally anyone sitting next to you can send you these, as many as they want, because they can see all the sessions that you had. They don't even have to guess. So like, I don't know why I didn't think of it before, but this like really seems kind of almost doomed, so.
That's quite hard to follow. Talking slightly less doomed, I think the second part of that question, which was using the new ICMP code to say, hey, your session's going to expire in 5 minutes. I think that's the wrong layer to be, well, not layer, I think it's the wrong channel to be sending those messages. That should be tied into the router advertisement or the DHCP or however we're doing the PVD stuff. That's sort of control plane rather than, hey, your traffic's not going anywhere. So I'd be against the second half of that.
Is there value in a destination unreachable type code point that says instead of network unreachable or instead of any of the other sort of failure cases that communicated by the subcode, one that just says captive portal enforced?
Oh, I think there's benefit in saying your destination is unreachable because there's a captive portal. Whether that is a subcode on destination unreachable or whether you want to do it the next code layer up, fine. What I'm against is having another ICMP message in there to say it's about to be unreachable. That's more of a provisioning thing and should be covered by the relevant provisioning protocol, not ICMP.
Okay. So now that we're coming up with new ideas, thanks, Lorenzo. So yes, I think there could be a generic problem if you just started sending unreachable back. Legacy captive portal approaches like probing would fall over, quite likely, right? Like you may actually block, like you may end up getting a different user behavior on devices. Is that a negative thing? Do we want to avoid that? Because one option we have is to say that we have a new ICMP unreachable code point that says, by the way, I'm captive. And this is coming from the enforcement device. And presumably the enforcement device knows whether or not you went through the captive portal API already. So you could imagine that, so it knows, have I ever opened this? So if I go through the new path to say I discover the captive portal API, I say, oh look, you're there. I'm going to open this up. The ICMP is a great way to say, now you have closed, right? To say you used to be open, now you have closed, and presumably anyone who's implementing the new captive portal API stuff would be aware of. We could say you have to be aware of the captive portal ICMP blocking responses and use that as a mechanism. But anyone who did not already open up their portal, maybe we don't generate the ICMP for them, or we generate it in some legacy compatible way.
Just jumping in, Rick Taylor again. You've got a very good point there, and I'm altering my opinion as I speak. The problem with saying destination unavailable with the ICMP message in the presence of a captive portal is that's actually not what happens in practice. If there's a captive portal in the way, there is a destination. It's just not the destination you thought it was. Hence, probing works. So having destination unreachable, no, that's actually the wrong response. And for all the reasons Tommy just came out with, yeah, it's going to baffle old kit. So a new code for those who are aware of it to say, hey, your captive portal, your traffic's probably not going where you think it is probably a wiser idea.
So does that sound like a reasonable way forward? Which is to say, let me say, Lorenzo raised a point. Does anyone want to speak to that point? Because I don't think we got there.
Let me ask another question. Like, is a clear text notification really the best we can do here? Like, we're defining a greenfield deployment with an API server, and we're really saying, well, the push strategy for this is basically an unauthenticated ICMP message. Is that really the best we can do? Can't we at least stuff a token in it or something?
Oh yes. So all right. Spitballing on this one on the fly. The ICMP unreachable contains a slice of the packet that triggered the ICMP unreachable. We can hash map that with the key that was advertised by the API server.
So that it's signed.
It's effectively signing it with a symmetric key. So it's cheap.
So somehow when you contact the API first, you learn like a public key or something of the and then it signs the packet with whatever private key was there. So you can now say these two devices know about each other.
A shared key would be sufficient in this case, I think. You do want to per user. It would have to be per user. That the API would advertise, because you're talking to the API over TLS. There's only two people who know this key.
Yeah, but then it's going in the clear.
No, it's not. If you have
but in the ICMP unreachable message, you're going to this is going to be encrypted, all of it. Then.
So the ICMP unreachable would contain something that is derived using a hash from the private key. Therefore, it would not contain any of the key. Therefore, no one could get it. And the only two devices then that are able to trigger this new behavior is the API device, anyone it tells the key to, and the endpoint, anyone it tells the key to. And I think those two are the.
Kyle Rose.
New API document authors take note.
There's sort of two things related to this. So the first is that one of the things we envisioned initially was that you wouldn't be required to talk to the API server to make this whole thing work. That you could just join the network, and when connecting externally, the ICMP would come back and say, "Hey, crap, something's wrong. Go and connect." And this would help if you accidentally disconnected or your computer rebooted and you lost your session ID or something like that. The second thing is that there's some nice properties with the destination unreachable, in that if I tried to do an HTTPS connection attempt, rather than saying you're hijacked, oh my god, it just says you can't go. It doesn't work. And I prefer that my HTTPS connection just fails, as opposed to telling me that I'm on an insecure network and I'm being, man in the middle.
Ben Schwartz. I just want to point out that it's not obvious that there's enough entropy for this HMAC to prevent replays. Because I don't know if the packet it's replying to is actually a SYN packet. Like, there's not a whole lot of entropy in there. But there's probably a design with a counter or some additional entropy, some replay
Cram
resistance.
the nonce in there. That'll work fine.
No worries. I don't understand the officials.
Yeah, so just to Kyle's points, I think we should discuss whether or not we want to keep the assumption that you don't have to talk to the API server, because I feel like if we want to have you essentially blocked later and then you go talk to the API server, clearly you have written the code to be capable to talk to the API server. So you may as well do that at provisioning time. If you're not capable of talking to it, I feel like we're kind of in the existing captive portal world, and we haven't moved the ball forward. One nice thing is if we use something like the API server to be the bootstrapping factor, then we can, from that point on, essentially clearly distinguish on a captive portal enforcement device people who have kind of gone the legacy way and people who have gone the new way. And so that actually also creates a transition mechanism in which they can kind of know per thing that they're blocking or allowing how that actually got in there. So if there are other reasons why we think the API is not a requirement to be able to interact with, I'd like to hear that.
I don't think the full solution. I think the full solution certainly needs an API server. I mean, it's like you can't just being told you're behind a captive portal isn't super helpful. You need to tie it all together. But I guess can ICMP on its own at least improve what we have now, even if it's not making it so you log in, pop up the page and automatically, things like that.
We're down to 5 minutes.
Does it really help by itself? Like by itself?
No, I don't think it is.
It's like, suppose that you because by definition you have a new client, you wrote some code and it understands ICMP. What do you get? Nothing? Okay, well.
No, but I mean, if you get an ICMP and reachable right now, you close a session. I mean, unless you're blocking ICMP.
And so your new code does what for you? The code that you just wrote.
You haven't written code yet. This is for existing clients.
No, we can't break them.
How is that breaking them?
So today, let's say I'm running current version, this year, iOS 11, iPhone joins this captive portal. I try to load random clear text web page because I know I need to get onto this portal by using a clear text web page. I get unreachable. I close the connection. You can no longer join the portal ever on any device that was built before next year.
All right. Unless that clear text web page.
Last comment, Rick.
Do you want on the mic?
Last comment.
My last comment was the answer to the question of the ICMP message without a captive portal API URL. That's just a firewall. So actually that message can be used by polite firewalls to say, hey, you don't get access beyond this subnet.
Which you can do today.
Which you can do today. But it gives you a nice little message so that it's extending the scope of what we're trying to do here. And it's not this working.
To do what you could do today in a nicer way.
Yeah, but you can get a nice little icon on your handset.
I got it. That's awesome.
Okay, thank you all. I think we have some discussion of identifiers and so on to look forward to on the list. We also have a new API document to look forward to with some awesome crypto to look forward to. Always very exciting. Hope to see people in London. Safe travels and happy holidays. Right. By London, we need to have some architecture assumptions nailed down so that we can say this is what we're doing and moving forward. I believe, yes. Thank you, Adam. Tommy, I have your HTML.
Give my document. Oh, you don't.
Okay.
Yeah.
Surprisingly constructive. Yeah, that meeting went a lot better than previous ones.
Yeah.